Hi everyone, the question is, let S be the set of all points a by b comma c by d on the circle with radius 1 centered at origin, where a and b are relatively prime integers, c and d are relatively prime integers. That means HCF of a and b, HCF of c and d both are 1, and the integers b and d are even. Then the set S has how many such elements? So that means a by b comma c by d, a by b is the x coordinate, c by d is the y coordinate of a point lying on the circle x square plus y square equal to 1, having center at origin and radius 1. Yeah, so that means it should be satisfying. A by b comma c by d should be satisfying this. Yeah, so here you can take x to be a by b, and you can say y square would be what? 1 minus a square by b square. Or you may say what? You can say it will be b square minus a square by b square. Yeah, clearly a by b and c by d both are supposed to be less than 1. Yeah, because here clearly c and d are relatively prime, and if d is even, c has to be odd, so c can't be even 0. Yeah, that's why strictly less than 1 we have told. And similarly a and b are relatively prime, b is even, so that means a is odd. So a and c both are supposed to be odd. Yeah, so here you get y to be plus minus root b square minus a square by, you may say, b. Now you may see b as whether it is positive or negative, so we should keep mod sign, but we have already considered that by taking plus minus. Yeah, so here you can compare it with c by d. Nonetheless, clearly b square minus a square has to be perfect square. Why? Because if b is rational, then under root b square minus a square should also be rational, so that overall expression is rational, because c by d is supposed to be rational. Yeah, so b square minus a square is supposed to be let's say k square. Yeah, where k is some integer, where k is definitely some integer. Yeah, now we have already talked about this thing and convinced ourselves that given that b is even, then a has to be odd, because a and b are relatively prime. Yeah, so b square is even, or you may say is square of an b is an even number, so b square is square of an even number, so I can say even square, so to speak. Yeah, and a is odd. Now clearly even square would be even, and odd square, because a is supposed to be odd, so odd square would be odd. So even minus odd is going to be odd, is going to be odd. And since k is supposed to be an integer, that means if k square is odd and k being integer, k has to be odd. Yeah, so let's take let's take b square. I am writing now here b square is equal to a square plus k square. Now since a is odd and k is also odd, you can say for example 2 lambda plus 1 whole square plus 2 mu plus 1 whole square. Yeah, so this essentially becomes what? 4 times lambda square plus lambda plus mu square plus mu plus 1, which is 2. And b is supposed to be an even number, and now square of an even integer is of the form, you may say 4 alpha. Yeah, where alpha belongs to positive integer. Yeah, because if b is of the form, let's say 2m, then b square would be what? It will be 4m square, and it will be multiple of 4, while the right hand side is not multiple of 4. Yeah, it is not multiple of 4. Yeah, hence you may say it is a contradiction, and you can say that no such ordered pair a by b comma c by d, that means no such point a by b comma c by d would lie on this circle with radius 1 and center origin with given conditions. So this set S is an empty set. Thanks for listening. Stay tuned.